Hello, everybody, and welcome. I'm going to walk through a little bit of IBM SPSS statistics, just to go over kind of what we did in class and reinforce a little bit of the way that we can work within SPSS. So I just logged into Oporto, and so if you've never done that before, from our course website, our course Canvas website, it is Oporto Virtual Software. When you click it, it'll open up a whole list of apps or applications. And IBM SPSS Statistics is right here under Excel, and all you have to do is hit launch. When you do that, it'll automatically open up, and you'll have kind of a replicated desktop, so to speak. And if you want to upload a file to the desktop, all you have to do is hit this little up arrow into the cloud and be able to select the file you want to add. If you want to take a file from your desktop to your local computer, I believe all you have to do is hit the down arrow on the cloud, and it may take a sec. It notices that we have files on my desktop right here. And so if we wanted to download the syntax file, I would just do that and click download, and it would pull it out. So it's pretty handy. I really appreciate this software package and ability to use this. So in SPSS, the first thing it asks you to do is if you want to open a file, we want to open the week 4 in class file. So I will just double click on open another file, and eventually I will get up here to the desktop, and it doesn't show up as an Excel file. So I notice that the file type menu is down here, and I'll change that to Excel. And there it is, our week 4 in class Excel file. Now that I've got it open, I want to make sure I select the right worksheet. So sheet 1 doesn't have all the data, but the data tab does. And you'll notice I've got all the data here. I can take a look at it, and I see everything looks good. I don't have any hidden rows or columns. If I had hidden rows or columns and this was checked, those columns or rows would not be brought in to this SPSS environment. So that's not relevant today, but just know that in case you like to hide rows or columns in Excel, it will ignore those if you have that box checked. Okay, so we'll hit OK, and the data file will be brought in. And here is our data set. I'm going to expand this to make it a little bit bigger on your screen. And what you should notice is that we have a data view tab and a variable view tab. Unlike Excel, which you can have numerous tabs, however many tabs you want, SPSS has the data on one tab and what's called the metadata, data about the data, on another tab. And so on the variable view tab, it tells you what each variable's name is, what type of variable it is, how wide it is in terms of the length of the variable. So you can see institution name is a pretty wide variable. It has at least 59 characters or less, due to the institution names being pretty long, right? And so we don't have any decimals except for the latitude and longitude, because those are many decimal points attached to them. The label is usually copied from the row, the first row being recognized as the variable name. But if we wanted to change the label to just institution, you can just double click it and pick off name. And same thing for each other variable. We can edit them however we want. And if we ran analysis, getting, let's just say, breakout by control, frequencies by control, it would only show the word control. It wouldn't show control of institution HD 2019. No need for all of that. So we'll just kind of clean up a couple of these, and applicants, admissions, and enrolled. All right, great. Now, the values themselves are not defined here in SPSS, but we know, if we look at the data view, we have categorical data for control and level. 1 means something, 2 means something, 3 means something, and vice versa. So what we want to do is we want to define what the values are for control. And so one for control is public. A little bit of delay and moving over, and that's there it is. Okay. Give it a second to catch up to me. I might be going too fast. While that's catching up, essentially we'll create value definitions for each of those, and that will allow us to organize our results in that way, not just showing people that 40% of the institutions are a 1, 20% are a 2, but that it's more meaningful to know that 40% of the institutions are public, right? 20% are private, nonprofit, and that sort of thing. Well, it's not responding super quick to me, so I'm just gonna pause the recording and then come back whenever it's ready. Okay, so it's caught up to me now. I've typed the word public, and what I need to do next is hit add. If I just hit OK, that won't be saved, so I have to hit add it officially. 2 for control is private. Well, add that as well. And 3 is private. And once we're done, we hit OK. And you notice it fills in those values. Now we also want to define what the levels are. A level of 1 is 4 year or higher. 2 is at least 2 year. 3 is less than 2 year. So like technical schools and that sort of thing. We'll hit OK. And there they are, they're defined. Wonderful. So now we've got our values defined, but we know in our data that we have a lot of institutions that have this 999999 field value for admissions, applications enrolled. As I told you before in class, 9999999 is actually means that we don't have data for those. So we're going to put 9999999 as a missing value. And we have to select discrete missing values. And we'll just type 99999. Okay. And because that same value is missing for applications, admissions, and enrollment, all we have to do is click and paste, or right click and paste for each of them. And now we've defined the missing values for each of those. So now that we've got our variables kind of cleaned up, let's go take a look at the data again and just make sure that everything looks okay. What I want to do now is I notice that we have the number of applicants, the number of admissions, and the number of enrolled. I'd like to compute or calculate a variable that shows each individual institution's percent of students who applied that got admitted and the percent of students that were admitted that enrolled. And the way we do that is to go to data, or rather, transform, and compute variable. And all we have to do is name the variable that we want, and we'll call it percent admitted. And it's already set up like an Excel equation that starts with an equal sign. So we bring our cursor over to the numeric expression and we just enter it like it's a mathematical formula. So number of admissions divided by number of applications is the percent admitted. So double click admissions, put in a divisor sign right here, and then double click applicants total. And that's our percent admitted. All we have to do is hit OK. And you'll notice our output tells us what we did. And here on the data view, the percent admitted is calculated as well. So that variable is now created. Let's do that again. But this time, let's do the yield. The number of students that enrolled divided by the number of students that were admitted. So we'll change the title to percent yield. And then we'll bring in number enrolled divided by number admitted and hit OK. And we'll see another variable get created here for percent yield. So now that we've done a couple of computations, creating new variables that we didn't already have, now what I want to do is show you how to select and organize our analysis in different ways. If we wanted to show results by only looking at each individual control or level, we could select split file under the data menu. And split file allows us to tell SPSS, whenever we analyze cases, we want to compare them by groups, and we want those groups to be organized by control. So publics, private nonprofits, and private for-profits, all separately analyzed. So all you have to do is push the little arrow over and bring control in. And now we say, okay. And it does a little bit of a split file, right? Command there. And now what we can go to is under analyze, and I'm not going to get too deep into all of these different sections because we're going to go over some of those later on in the semester. Let's just do a quick descriptives for admission, enrolled, and percent admitted, percent yield. So we'll go to descriptives and say, okay, what do we want? Well, we want the number of applicants, admissions, enrolled, and percent admitted, percent yield. So we can select all of those by just holding down Shift and clicking and then bring them over. Or if you just want to bring one over, just double click it. We want latitude, so put it back. And we'll go to options. And we want to make sure that all of the things that we want are selected. So we've got average, standard deviation, min and max. If we wanted to look at kurtosis and skewness, we could select those as well. And then hit continue. Now, normally, like I've done before, we would just hit OK, but I want to also show you that we can save our syntax, or actually save the commands that we're trying to run by clicking paste. When we hit paste, it actually makes a log of what we want to do and allows us to come back and rerun this at any point in time. Let's say if we wanted to organize our output by control on this go around, but next time we wanted to organize it by level, all we would have to do is go back and change the split file, and then we could organize it by level, which is really, really nice. So there goes my syntax. Okay, so when you get to the syntax and you paste, all you have to do is press this little green button, and it runs the selection. And now what we're going to show is some output, hopefully. But it looks like we have an error message. So let's see what it says. Okay, so maybe the split file is not working. So let me come back up here. Let's take off that split file and see what we get. So brought up the split file. Let's take off control for this example. Let's just show it for everybody to start. Let's click back on Analyze All Cases and hit OK. And now let's rerun our analysis just to make sure. And find our output. There it is behind it. Okay, good deal. So now we want to run our descriptives. There we go. It looks like, oh, and by the way, we have multiple years here. So we definitely want to split the file by the years, or otherwise it could be difficult to understand these statistics. So actually, let's go back to split file. And I'm going to split it out by the year. And there we go. Now let's rerun our syntax. You see how quick this can be whenever you have it up. There it is. Now what we see is looking at number of applicants for the 54 institutions or 52 institutions that reported application data. We see that the average number of applications ranges from about 4,400 to about 5,700. Standard deviation, all of those great things. Average percent admitted, average percent yield, good stuff here, right? Now let's go back, and so we want to split the file again, but this time let's do it by level as well. And so let's hit OK. And hit our syntax again. So now that we've split the file out, let's hit syntax again. And so it looks like basically what SPSS is telling us is they're saying, warning, warning. There are no statistics to be computed because there's no valid cases. Remember, less than 2-year institutions may be considered an open enrollment institution, so anyone can enroll, much like our 2-year colleagues, our 2-year institutions. So you see here only 6 institutions reported admission data. 4-year institutions, they generally are the ones that are reporting it. So you know what? That makes sense. Now that we kind of understand how higher ed works in that regard, let's just only select 4-year institutions. So let's take level and do an if condition is satisfied under select cases and say if level equals 1. You see how we did that? So we brought it over and we said if level equals 1, we're going to select only those cases. And so now what's going to happen is all of the at least 4, but at least 2 but less than 4 and less than 2, all of those should go away. Let's rerun our analysis for descriptives. And look at that. 4-year or higher, 4-year or higher, 4-year or higher. Isn't that cool? Now that we've got only 4-year under select cases, we can actually take it out of the split file because it's the only level we have. So just to make sure we got it right, let's do it again, clean it up a little bit. Now we just have 48 institutions, 4601 average applicants, 48, 4601. Yep. So we're only looking at 4-year institutions and we're grouping them by year. Pretty handy, cool stuff. And so those are just examples of how you can split your file, select your cases, as well as compute variables, and be able to run at least some descriptives there. I don't want to get too deep again in some of this because it's going to come in a little bit later, but it is important. So we've gone over a little bit of the transform. We'll do some more recoding in a later video. But at least for this initial walkthrough, I know we talked about recoding last week or this week, but I still wanted to, just focus kind of on what is most pertinent for y'all right now based on the data file that we use. So to finish up, SPSS is also not like Excel in the sense that if you just hit save, it saves everything. All 3 of these windows are 3 different files. So we need to save each of them individually. The output is an SPO file. And so we'll save that as a viewer file actually on this one. That's interesting. For me, it's an O file. Apologies for that. SP viewer file in Oporto. I should fix that slide in my presentation. SPO is what's used on version 25.26. But nonetheless, so SPV here, and let's replace it. And then the actual data set is an SAV, and you can consider that like data A and variables B. So let's save that as well. And I'll just save it as in class. And then the syntax should be an SPS. Yep, SPS. S is for syntax. And so what we'll do is we'll save that one also. And so now what you'll note, and the reason we have to save each of them individually is because you can close each of them individually. I can close my syntax, but still keep everything else open. As soon as I close my output, it's gone, but the data file itself is still open. So with that, happy exploring in SPSS this week. I hope you found this demonstration to be helpful.